You are warmly welcome back to GordMaths. I hope you have already subscribed to our channel. This is our series on geometry, and today's lesson focuses on circle theorems. Stay tuned. The main objective of this lesson is to enable students understand the 8 basic theorems of a circle and to also enable them apply it in solving problems. Now let's get started with the theorems of a circle. The first theorem of a circle is that the angle subtended at the center of a circle by an arc or a chord is twice the angle subtended at the circumference of the circle. That is when they are in the same segment. And so if we have a circle with center O, then the angle that is at this center is equal to the angle that will be subtended on the circumference of the circle, provided that angle is subtended by the same arc or by the same chord. And therefore, if this angle is 20 degrees, then the angle at the center will be 40 degrees. Suppose I extend another angle from the same arc, then this angle is also going to be 20 degrees because it is subtended by the same arc or the same chord at the circumference of the circle and in the same segments. Now, the second theorem of a circle is that the angles subtended at the circumference by the same arc or chord in the same segment are equal. So if we have a circle and then an arc or a chord is drawn, then the angle that is going to be subtended by that arc or a chord should be equal, whether that arc passes through the center of the circle or not. And so if I extend another angle from the same chord onto the circumference of the circle in the same segment and label that angle Z, then this angle is equal to this and also equal to that, provided it is subtended by the same arc. Now, if we have a circle, then we have a chord PQ of the circle. This chord subtends an arc onto the circumference in the same segment. And let's suppose this angle is 30 degrees. Then any other angle that will be subtended by the same chord is also equal to 30 degrees. That is the second theorem of a circle. Now we will look at the other theorems of a circle. The third theorem of a circle states that the angle that is subtended at the circumference by a diameter is 90 degrees or a right angle. The diameter is that line which moves from one end to another and passes through the center of the circle. Now from our first theorem, we realize that if a chord or an arc subtends a certain angle at the center of the circle, then half that angle is subtended at the circumference. Taking this arc AB, then at the center the angle subtended here is 180 degrees. And so on the circumference, half of 180 will give us 90 degrees. That is from the first theorem. And so angle ACB in this diagram is equal to 90 degrees. Then the fourth theorem states that the opposite sides of a cyclic quadrilateral are supplementary, or the opposite angles of a cyclic quadrilateral are supplementary, which means they add up to 180. A cyclic quadrilateral is a quadrilateral that is inscribed in a circle, that is drawn in a circle and the edges touch the circumference of the circle. And so when we have a cyclic quadrilateral like we have in this case, then the opposite sides of that quadrilateral add up to 180. We say they are supplementary. It is not only these two sides. These angles are also opposite angles. And so when we add them, they should give us 180 degrees because they are opposite sides of a cyclic quadrilateral. We will take a few examples on the first four theorems of a circle. Let's find the values of the letters in each diagram, where O is the center of each circle. Now looking at the first diagram, and from the four basic theorems of a circle that we have discussed earlier, you would observe that from this chord, we have different angles extended. And then from the first theorem of a circle, we learned that if a chord extends an angle at the center of a circle, then the angle subtended at the circumference is half of the angle subtended at the circle. Or in other words, we say that the angle subtended at the center of the circle is twice the angle subtended at the circumference, provided they come from the same arc or the same chord. So from this, we will say that M is equal to 2 times 50 degrees, twice the angle at the circumference, and that gives us 100 degrees. Then again, from the second theorem, we learned that if an arc or a chord subtends angles at the circumference of a circle in the same segment, then those angles should be equal. And so since the angle 50 degrees and the angle N are coming from the same arc and subtended in the same segment and on the circumference, we would say that N is equal to 50 degrees. Then we can say this is angles subtended by the same arc. By same arc. Let's go to the second example. There is a cyclic quadrilateral in this circle. Now, you also have an arc that is subtending an angle at the center of the circle and another angle at the circumference of the circle. So still from the first theorem, we would say that 108 is equal to 2z. The angle at the center is equal to 2 times the angle at the circumference. So we divide both sides by 2, and then our z will be equal to 54 degrees. Now in finding the value of x here, our fourth theorem says that opposite sides of a cyclic quadrilateral, or the opposite angles of a cyclic quadrilateral, that is a quadrilateral inside a circle, add up to 180 degrees. And so since z and x are opposite angles of a cyclic quadrilateral, we would say that x plus z is equal to 180 degrees. We already know the value of z, so x plus 54 degrees is equal to 180 degrees. Then our x will be equal to 180 degrees minus 54 degrees, which will give us 126 degrees. Then again, in finding the value of y from our elementary geometry, we all know that the total angle inside a circle, this is forming a complete circle, is 360 degrees. And so y plus 108 degrees should give us 360 degrees. Then y will be equal to 360 degrees minus 108 degrees. And that should give us 252 degrees. We would also look at the next 4 theorems of a circle and take further examples from there. The 5th theorem of a circle states that equal chords subtend equal angles at the circumference or at the center. And so when you look at this diagram, we have 2 different chords which are equal. This mark indicates that these 2 lines have the same length. So the chords are equal here. And so the angle that they subtend at the circumference of the circle should also be equal. Therefore, x is equal to y, or y is equal to x. Now suppose you have another circle with center O, and then you have 2 different chords where the chords subtend angles at the circumference or at the center of the circle, where the 2 chords, this chord and this chord, which are equal, subtend angles A and B respectively at the center of the circle. Then, since the 2 chords are equal, we will say that angle A is also equal to angle B. Then to the 6th theorem of a circle, it states that 2 radii and a chord form an isosceles triangle. An isosceles triangle is a triangle that has 2 sides to be equal. Now, you should note that the radius of a circle is equal. And so when we draw one line from the center to the circumference, draw another line from the center to the circumference, those 2 lines are both radii of the same circle, and so they are equal. Since 2 sides of this triangle are equal, then we will say that the triangle is an isosceles triangle. Also, the sum of angles in a triangle is 180 degrees. And so we will have x plus y to be equal to 180 degrees. Then y will be equal to 180 degrees minus 2x. That is 2x here crossing to the other side of the equal sign. We will also look at the final 2 theorems of a circle and then take further examples. The 7th and 8th theorems of a circle are supplementary properties of the circle. Now, if you look at this diagram, you realize that AOB is an isosceles triangle. From the previous theorem, we have seen that the radius or 2 radii, when they meet a chord, form an isosceles triangle. Now when we draw a line from the center of the circle to the chord, then that line is perpendicular to the chord and also divides the chord into 2 different halves. This is because the chord is the base of the isosceles triangle AOB. And so from this diagram, we would say that line AX is equal to line BX, which is equal to half of the total line AB. Or we can say that the line AX is half of the line AB. And then the line BX is also half of the line AB. These are basic properties of an isosceles triangle. And now to the 8th theorem. This is a combination of 2 different properties of the tangent of a circle. Now, a tangent is a line that is drawn outside the circle and touches only one point on the circle. It touches only one part of the circle and it is drawn outside the circle. We call that line a tangent. When we have a tangent to a circle and the radius of a circle meeting at a point, then the angle that is formed at that point is 90 degrees. And so the angle OPQ, which is formed by the tangent PQ and the radius OP, is equal to 90 degrees. And then the angle ORQ, which is formed by the tangent RQ and the radius OR, is also equal to 90 degrees. In short, we say that the tangent to the circle and the radius of a circle form an angle of 90 degrees when they meet, or they are perpendicular to each other. Then, when we have two different tangents to a circle drawn from the same point outside the circle, as in this case where the two tangents are drawn from the point Q, then those two tangents are equal in length. We will take further examples on all the properties of a circle. Now let's go through these two questions. In a diagram, PT and QT are tangent to the circle with center O. Then angle PTQ is 40 degrees. So this angle is 40 degrees. Then we want to find the angle POQ. Now, we have learned from the theorems of a circle that the angle that is formed when a radius and a tangent meet is equal to 90 degrees. So, radius OP meets tangent DT. The angle is 90 degrees. Radius OQ meets tangent QT, and the angle is 90 degrees. So, we will state that from the diagram, angle OPT is equal to 90 degrees, and then angle OQT is also equal to 90 degrees. Then the sum of angles inside a quadrilateral is 360 degrees. A quadrilateral is any four-sided figure. So since this figure has 1, 2, 3, 4 sides, we will say that it is a quadrilateral. And the sum of the angles inside a quadrilateral is 360 degrees. So we will say that since sum of angles inside the quadrilateral OQTP is 360 degrees. Then the sum of angles will be, we have 90 degrees plus, next we have our angle POQ plus, we have another 90 degrees plus the last is 40 degrees, and that should be 360 degrees. Now when we sum these angles, we have 90 plus 90 plus 40, that gives us 220. So angle POQ plus 220 degrees is equal to 360 degrees. And then from there, our angle POQ is equal to 360 degrees minus 220 degrees, and that should give us 140 degrees. Then let's go through the second question. In the diagram below, P, Q, R, and S are points on a circle. P, Q, R, S are points on a circle. We have PQ is equal to PS, and angle PQS equal to 40 degrees. Angle PQS is 40 degrees. Angle QSR is 25 degrees. QSR 25 degrees. We want to calculate the value of the angle QPS. This is angle QPS. The angle will be formed here. And then next, we want to find the value of x. Let's do that. Now, note that QP and PS are chords. And since they are equal in length, we have also learned that equal chords subtend equal angles at the circumference of a circle. Realize that the chord PS subtends an angle of 40 degrees. And so the chord PQ will also subtend an angle of 40 degrees. This is PQ and it subtends this angle. So the angle here will also be 40 degrees. Alternatively, since these two lines are the same, the triangle is an isosceles triangle, and so the base angles are equal. Then, so we will say that I angle PSQ is equal to 40 degrees. Then we will state that as equal chords subtend equal angles. Or you can also state that angles at the base of an isosceles triangle are equal. So from there, we also know that sum of angles in a triangle is equal to 180 degrees. And so we have 40 degrees plus the angle QPS plus another 40 degrees is equal to 180 degrees. Then you state that as sum of angles in a triangle. So angle QPS plus 80 degrees is equal to 180 degrees. And then our angle QPS is equal to 180 degrees minus 80 degrees, which will give us 100 degrees. Now let's find the value of x, which is our II. This is x, and then PQRS is a cyclic quadrilateral. That's a quadrilateral which is inscribed in a circle. And from the theorems of a circle, the sum of opposite sides or opposite angles in a cyclic quadrilateral is 180 degrees. And so we will say that angle QPS plus angle X is equal to 180 degrees. That is sum of opposite angles of cyclic quadrilateral. So from here, since we already know the value of QPS, we will have 100 degrees plus x is equal to 180 degrees. So our x is equal to 180 degrees minus 100 degrees, which will give us 80 degrees. We will take another example. We want to find the value of x in the diagram below, where O is the center of the circle. Now, looking at this circle critically, since O is the center of the circle, this line is the radius of a circle. This line is also the radius of a circle. We know that when two radii meet a chord, then the triangle formed is an isosceles triangle, which means that since these two lines are the same, then the angle formed here is also 56 degrees. Now remember also that when a radius and a tangent meet, the angle that is formed is 90 degrees. And so the total angle here is 90 degrees. Since we have 56 degrees and 56 degrees, we will say that let's represent this by A. Then we will say that from the diagram, A plus 56 is equal to 180 degrees, since they are angles inside a triangle. And so A plus 112 is equal to 180 degrees. A is equal to 180 minus 112 degrees, and that will give us 68 degrees. But remember, it is x we want to find. And there is another triangle. Inside this bigger triangle, the angles are A, X, and then the total angle here, which is 90 degrees. The angle formed when the radius and the tangent meet. And so we would also say that A plus X plus 90 degrees is equal to 180 degrees, the sum of angles inside a triangle. We already know the value of A. So 68 degrees plus X plus 90 degrees is equal to 180 degrees. Then X plus, when we sum this, we have 158 degrees is equal to 180 degrees. So our X is 180 degrees minus 158 degrees, which will give us 22 degrees. Now there is an exceptional feature of a circle. That is the last circle theorem we are going to look at. Let's check it out. This is one special feature of a circle, and we are treating us as the ninth circle theorem. Now when we have the tangent to a circle meeting a chord on a circle, then the angle that is formed between the tangent and the chord is equal to the angle that is subtended by the chord on the circumference of the circle. The angle that is formed between the chord and the tangent to the circle is equal to the angle that is subtended by the chord on the circumference of the circle in the other segment. And so from this diagram, angle X is equal to angle Y. Let's use the example to explain this concept. Now in the diagram below, KS is a tangent to the circle at R. Angle ROQ is equal to 80 degrees, where O is the center of the circle. We want to find angle QRS. This is the angle at R, the angle between the chord and then the tangents. So we want to find this angle. Now in the previous theorems, we have learnt that when a chord subtends an angle at the center of a circle, that angle is equal to twice the angle that is subtended at the circumference. So suppose we extend another line from the chord onto the circumference to form an angle and call that angle X. Then from the first theorem we learned, we would say that 80 is equal to 2x. The angle at the center is twice the one at the circumference, 80 degrees. And so when we divide both sides by 2, we will have our x to be equal to 40 degrees. Then from this theorem, we have learnt that the angle that is formed between the chord and the tangent to a circle is equal to the angle that is subtended by the chord on the circumference of a circle. And so from this concept, we will say that our angle QRS is equal to the angle X, and that is equal to 40 degrees. This example brings us to the end of our lesson on circle theorem. If you have any questions or any extra difficulties, you are always free to contact us via the WhatsApp numbers displayed on the screen. Remember to subscribe for more interesting lessons.